Hey, it's Peter Diadamo with another short video to sort of go into the elements of what's called deep curation, which is the real hands-on curation component in Opus, which allows you to really create very, very tailored output for the client. And I'll show you how to do that in this short little video, which we'll go through the various elements of it. I think you'll also find that deep curation is, in many ways, some great capacity with regard to getting further insights into the client as part of the curation process. So in many ways, it actually serves as another tool for getting into a more focused way of looking at the data. The most important thing, of course, is to have a client loaded who you want to curate. And of course, that normally is done by the manage. And then we go to profiles, list and load profiles. I've already loaded my favorite test display, Mona Lisa 2021. You also know that in order to have a client in Opus, you need to have a valid slot for the available license, and just simply go through the simple ways of getting a client in, which is just knowing that the particular file that you have to use is a file from a recognized reporting service, 23andMe, Ancestry, Genomic Insights. It has to be a zip file of the text data storage, the raw data. This is normally the way it's delivered when you download data from the reporting service, download the raw data. Sometimes they'll send the raw data as a text file itself, and the best thing to do here is to simply, from any computer, I think a Windows or a Mac, you simply go into the file exploration tool and right click, and basically at that point choose the option to compress the file, and it will create a zip file of the text file. You can't really import PDF files. These are not data files, they're display files. And so just try to make sure that you get, and Opus will tell you if it has a problem with the file, but the end result is just make yourself life easier. Just make sure you have the right format from the start. It's got to be a text file from the raw data that's been downloaded from a recognized reporting service and has been compressed into a zip format. Opus will unzip the file and do its magic from there. But just make sure that it gets what it needs in order to be able to get the job done. Now I've got a file here, so at this point I think we'll just take a look at the nature of what we're going to be doing with regard to curation. And as you know, from the top here you have Curation Wizard, but then this is an option that you didn't see in your student thing, which is the option to perform deep curation. And deep curation can basically take the form of any number of different parameters. You can curate anything in Opus that's an entity. It could be a gene, it could be an algorithm, there could be a mind map known as a protocol, which we'll not get into because it's well explained in the help files, and it really just creates a kind of a therapeutic mind map for the client. Talks a little bit about the way it kind of visually illustrates your kind of thought processes. But also, too, more important is to be able to curate the agents that are coming out of Opus from the prescriptives and perhaps maybe foods as well. So let's start with the first thing we're going to normally do. But remember, curation can occur anywhere in Opus. So for instance, if I was to look at, in this case, let's take a look at the VDR receptor, and I would be clicking Opus Curation here. You can see that this has already been curated in this client because it's flashing green and says curated. If I want it to uncurate it, I just simply click it again and it will toggle back and forth. So we're doing good with that, but I just want to make sure that you understand that the same premise that basically applied to your test case applies to deep curation. Anything that you select for curation is going to go on and wind up in the report in some form or another. And it's the purpose of our combination here, to our conversation here, is to tell you how to get that into a report in the best way possible. So back to deep curation. Let's start at the top. Let's go to Genomic Curator. Now here we're looking at the curation of the specific genes that we're most interested in addressing in the program. The important thing also to understand is that Opus is extremely flexible, and you should not be intimidated by that because the flexibility usually results in giving you some sort of magical power. And the magical power with curation is you can have multiple data sets that you have decided to curate differently. So for instance, every time you curate an opus, there's always a default data set called data set number one. But let's say I have a client who first I am working with who I want to talk specifically about cardiometabolic issues. They're on statins, they're taking a beta blocker, or they're overweight. So we want to concentrate on cardiometabolics. I might design my entire initial curation to basically only involve those types of genes or those types of algorithms. So I could create a new data set later on when they come back and we want to address perhaps anti-aging or some structural thing. I can create a second data set or a third data set that represent much more discrete sort of interval type things rather than just giving the patient one huge report that basically goes from beginning and end, starts at the top of their head and goes to the bottom of their feet. So you would do that essentially by either working inside the initial default, which is dataset number one, or you can click on the upper left there where it says create new genomic dataset. But we're going to go with the default, and based on most people probably will do that. The genomic curator is very, very visual. So in essence, you're seeing here, at this point, you're seeing all the genes that I have over the time that I've worked with Mona Lisa curated. So this first draw here, okay, current selections, it's showing me what I have chosen so far to include in the curation. And that little tick there is what we are looking at. And by the way, see that little talk box? If I need to add a specific note to the client, I could basically have this embed directly when the actual gene information is printed in the report. Lectin sensitivity is often a result of IL-13 imbalance. There, I cannot type. I still cannot type. And then save the note. And here we go. Close out. Now when that prints, it's going to have that little additional thing I stuck in there. So in essence, we are now, but also too, once you go past the initial shelf of what you've selected, you can see here there's a whole bunch of other categories that Opus is giving you. Hey, these are the greatest hits of immunology, inflammation. Take a look at these and make sure that there's not a whole lot of orange here you need to be aware of. You can also avoid having to scroll infinitely through the thing by just going to the little pull down menu here, and it will give you only that particular drawer that you're looking for. You don't have to do anything, just ticking the box here suffices to result in the selection. So buttons you don't want to hit are clear data set selection unless you're really, really hell bent on starting from scratch. But once you actually, and it's the same thing here, if you want to untick, that takes it out of curation as well. So essentially anything I want to add, if I want to add in, I don't know, maybe there's some sleep disturbances, I would add PER2, and it tells me that, okay, now that's basically in genomic curation. So genomic curation is very, very valuable. Remember I said before how the curation process itself, oftentimes to give you much more focus about the kind of things that you should be looking at sort of more or less prioritizing. The algorithm curator is a same thing, default data set. You can create another data set if you want, but the default is always going to be data set number one. And we will get in different, this is more of a tabular type of selection process as far as curation. You can see here that these are the ones that have been curated. I like to make sure that I'm always looking for the true ones. Unless I've got a real interest in showing the person that there's something that they're not at risk for, in which case sometimes false algorithms should be included, because it's, if the person is worried about Alzheimer's and you've got a false algorithm for ApoE4, that's probably a noteworthy kind of inclusion. And again, you can tick the boxes that you want. You can, if you need refresher on the algorithm itself, you can click on that. It will bring it up in a pop-up. Most of the table data that is curation type stuff requires you to save it. So in other words, here you'd have to click Save Algorithm Curation Dataset. And you just simply do that and you get a nice happy message at some point and you're saved. So then we go deep curation. As I said before, protocol editor, we're not going to be that interested in. Uh, in terms of displaying, it's one you can certainly get from the help files and the user manual. And if there's any questions about it, I think we'll make a video for that separately. But really what I want to do is get you guys into deep curation at the most basic level as fast as possible. So let's go straight to agent curation. Again, it's another table, and here consequently we're looking at a value-added way of including supplements, nutraceuticals. And so you can see here that we're looking at a number index that's kind of indicating its specificity in terms of how appropriate it is given the overall tone of the genome. But of course, you can pick less indicated things that have specific indications for something that the client has that really is independent and even kind of genome-wide look at things. But Opus does kind of do a big scan and kind of gives you the nature of how this all basically prioritizes to sort of help you out. And again, it's the same thing as any tabular data. You're going to see what we've curated here. If I need to add anything, if I need to add, let's say, I don't know, methylcobalamin, I can do that. I can click Save the Current Curation Selections, and that now is part of the agent selection process that's going to be added to the report. Then we go to the next, which is the food curator here. Again, it's another table. What this has done is it's taken your selections from the Phantasmatron app and actually converted it into food selections. And so here you're looking at foods basically that have been identified as potential problematic foods. They always start off being curated, so you can more or less think about uncurating them. But the bottom line here is that these will be included where appropriate as advice. You can look at foods that might be more beneficial and what the things that they're looking for. And certain, of course, it's really quite simple. If there's a SNP or a gene that's enhanced by magnesium and the food is basically being identified as a high magnesium food, it starts to wind up in a much more beneficial way. There's more to it than that because oftentimes there might be multiple considerations that go into how a food gets evaluated. And again, I can undo and do from the column, save the selections, and at that point basically you've done all the components of the deep curation element. So the last thing you want to do is report routing. Which basically just simply gives you the opportunity to identify things that you're going to want to include in the report. You're going to include your genes, you're going to include your algorithms, your agents, foods, and then there's a few auto-curated ones. It'll produce a table of drug reactions that might be problematic or etiological associations, and you can include specific maps, for instance, that might be useful as well. And you can basically print an abbreviated report header if it's like you're doing one of those things where you're kind of like giving out your curation thing in little snippets where you're doing cardiometabolic one visit and oncology prevention on another. You don't need to keep repeating the 5 or 6 pages of the report where the report goes into bringing the client along with regard to the significance of SNPs and things. So, and you can produce a much more shorter document. Again, once you save these selections, you're going to go to, at that point, you'll have the opportunity to see this link here, Generate Client Report. And there's your client report. It's actually printed to the screen, but you're going to want to then basically just go to your browser and choose print, and you can print it either directly to a printer or you can print it to a PDF. And it's looks kind of nice on the screen here, but it's really much more designed for printing output. So it's really designed for the printed page, even though it does look well on the screen here. Again, each thing basically is brought into the mix as needed. So in this case, we've curated NR3C1, nucleoglucocorticoid receptor. What you see here is one of the power of Opus, where basically it starts to embed components into the description that you may not have even had part of your working knowledge. And one of the most important things is this little owl here who comes along and kind of introduces concepts that the patient or the client might not understand, but really is really something that is important for them to get. So Opus has its own glossary, and if a concept is explained in the gene explanation that Opus feels it needs to explain, it'll come out and it will explain it one time. So the first time that that word is actually found in the course of the description, this little owl will come out and tell them about the new concepts. Then you'll have a discussion of if there are particularly noteworthy SNPs or if there are any high value foods. And then again, all by category. And we will really look at this as a kind of a really deep dive. A lot of patients have, they come in afterwards, they got this thing all marked up. They want to understand. And really what we're looking at here is the ability to bring a subject that's by nature complicated into a realm that makes the patient understand or be willing to undertake that process to get to understand things a little bit better about themselves. Um, Here you can see the integration of one of our curated natural products, resveratrol, was cross-referenced and found to be useful for a curated gene here. And we didn't have to do that. Opus does that automatically. And here, problematic foods or high-value foods. Again, so going through this, we see the need of visual manifestation. So here we see this is actually the power factor SNP little map. So we can see here that the orange color indicates that there's a lot of SNP power factors that are homozygous for the risk allele. Here we see mostly heterozygous for the risk allele. And remember, this is a test thing. This is not really a real curation at this point, but mostly it's just been used so many times that there are so many things in this curation that were ticked to sometimes prove that you can tick it. And again, environmental factors that basically get woven in here. Opus does a real nut job of using AI to sort of embed significance into the description. And then we basically wind up at the end, and remember, we curated a lot of genes here, so we're going to just take a moment here and scroll down. Certainly, I don't think you would want to curate this many genes, but it does show you that the variety of ways genes can actually find information kind of put into there. We get to the algorithms. Algorithms much more easy to understand for the layperson. You have a greater risk of having macular degeneration or something. And again, they all fall into this realm of good or bad selection process. Then we wind up with after we get through the algorithms, we wind up with a discussion of some etiological factors that they might be wanting to look at, beneficial foods that came out of the phantasmatron, problematic foods. Remember, we looked at curated agents, and here they are, and here are the genes that the agents showed some specificity for. So if those genes were part of the curation, a discussion of that particular agent would be embedded right under that gene. And then finally, drug reactions and our included maps. So in many respects, a curated report can produce a lot of information, and you have to be very careful about not wanting to overwhelm the client with things. And again, I apologize that really this is a overly curated person. You wouldn't normally expect to see 59 genes curated, but or a bunch of false algorithms included, but they're here. So I apologize if scrolling gets you all freaked out, but you're curating typically, I don't know, 15 20 genes at most, and maybe 8 or 9 algorithms and some natural products. And if you're going to do anything more, my advice is create another data set and do it on a subsequent visit that's got a little bit more detail to the specificity of what you want to address on that visit. So here, I hope that basically this has made the notion of deep curation more exciting. And it's really not an endpoint. Actually, sometimes I go to the curation tables as a quick way of being able to get some insight into things I need to be thinking about curating. Isn't it odd? Because you can do on-the-fly curation via the pop-ups and all your various explorations. But then sometimes you go to deep curation, sometimes makes it a very, very quick way to be able to get, yourself focused around the things that are going to be most important at that time and place. So with that, I end. I wish you well. email me if you have any questions or issues about how to use the program, and we'll be soon talking, hopefully, to some of you about getting a little bit more advanced training. So take care, be well, and thank you for your interest in this program, which I have enjoyed as much using as I have in creating. Take care now.